Hello everyone, in this video I'm going to show you how to solve these compound inequalities with absolute value. Let's get started. To solve this first inequality, we may split it into two inequalities. So this is equivalent to 0 less than absolute value of 2x minus 7 and absolute value of 2x minus 7 is less than or equal to 5. Now, if we look at this first inequality, the right-hand side, because it's absolute value, we know that its value is always greater than or equal to 0. So, therefore, this inequality here is true as long as 2x minus 7 is not equal to 0. Because if it is not equal to 0, then its absolute value is positive. So therefore, our inequality is true if 2x is not equal to 7. That is when x is not equal to 7 over 2. For this second inequality, so we may write this as a compound inequality 2x minus 7 greater than or equal to negative 5 and then less than or equal to 5. And we can add 7 to all sides of this compound inequality. And this will give us positive 2 less than or equal to 2x less than or equal to 12. And lastly, dividing all sides by 2. So we keep the inequality symbols because 2 is a positive number. And we'll get here 1 less than or equal to x less than or equal to 6. Therefore, we need to satisfy these two conditions. That x should not be equal to 7 over 2 and x should be from 1 to 6. Therefore, what is the solution set? The solution set is the union of the intervals 1 to 7 over 2. So we have to exclude this 7 over 2 union with 7 over 2 comma 6, including 6. So this is the solution set to our inequality. Now, how do we solve this second inequality? So let's recall that absolute value of a is actually equal to square root of a squared. Therefore, using this equation here, we can write our inequality as square root of the quantity 3x plus 1 quantity squared greater than or equal to square root of the quantity 3x minus 5 quantity squared. And then now, because the left-hand side and the right-hand side are both greater than or equal to 0, so we can square both sides of this inequality and the inequality will still hold. So in this case, squaring both sides will give us 3x plus 1 quantity squared greater than or equal to 3x minus 5 quantity squared. And if we expand these squares here, so we'll get here 9x squared plus 2 times 3x times 1, so that is 6x, and then plus the square of 1, which is 1, greater than or equal to square of 3x, which is 9x squared, and then 2 times 3x times negative 5, so that will give us negative 30x, and then plus square of 5, so that is 25. Now, isolating the variable terms to the left-hand side of this equation, we'll get here 9x squared minus 9x squared, and then plus 6x plus 30x. So don't forget to change the sign of the term if you move a term from one side to the other side of your inequality. And then you have here 25 minus 1. Simplifying this left-hand side here, we'll get 36x greater than or equal to 24. And dividing both sides by 36, so this will keep the inequality symbol because 36 is a positive number. So we'll get here x greater than or equal to 24 over 36. And the right-hand side can be simplified to dividing the numerator and denominator by 12. So we'll get here 2 over 3. Therefore, the solution set to our inequality is the interval 2/3, including 2/3 to positive infinity.